My dear students, once again I welcome you all to my channel Abrar Sir classes. Today we'll be seeing some important problems on the chapter Newton's laws of motion. This is part 11. Kindly go through the previous parts also so that you can understand the problems very clearly. This is the first problem. It is saying the system shown in the figure is in equilibrium. Find the initial acceleration of A, B and C just after the spring 2 is cut. Now, first let us see what is there. Okay, how many springs are there? 1, 2, 3. Okay, how many blocks are connected? 3 blocks of mass M, 2M, and 3M are connected. Okay, before cutting the spring, first let us write the weight here. Okay, this is 3mg. This is 2mg. This is mg. Now let us write the spring force. Here it will be kx3. I will write here. Kx3 is directly 3mg, and here also kx3 that is equal to 3mg, and here kx2 will be equal to 2mg plus 3mg is 5mg. Kx2 is equal to 5mg, and here let us write kx1. Kx1 is equal to mg plus 5mg is totally 6mg. Okay, now we are supposed to cut the spring 2. Okay, if spring 2 is cut, okay, if this is cut, if this is going to be cut, what will happen? Now I will okay, this is going to be cut. What happens to kx2? Kx2 will become 0. Kx2 will become what? 0. Now here mg will be there, and here how much was kx1? Just now we saw kx1 was 6mg. Okay, now there is no effect on the spring force. This will be 2mg as it is, weight will be as it is. Okay, now there will be no effect on the spring force. How much was kx1? Kx1 was 3mg itself. Instantaneously kx2 becomes 0 if we cut. Okay, spring 2 is cut. Here spring 2 is cut. Therefore kx2 is equal to 0. There is no effect on kx1 and kx. There is no effect on kx3. Okay, this is 3. I think we are written kx, right? There is no effect on kx3 and kx1. This is kx3. Kx3 will be 3mg itself that we have written already here, and then kx2 is 0 and kx1 is 6mg. Hope you have understood. Now let us write the acceleration. Where will be the acceleration? See here, kx1 is 6mg, mg is downwards, therefore acceleration will be upwards. Yeah. What about here? This is what? 3mg is here, mg is, this is a little bit downwards. What about here? AC 3mg, 3mg. Okay, here forces are balanced, therefore AC is equal to what? 0. AC is equal to 0. Now let us find, to find AA. Okay. Now apply Newton's laws of motion here. Chalane wala minus rokne wala. Which is chalane wala? Chalane wala is in the direction of acceleration, that is 6mg, minus rokne wala means this one, minus mg is equal to mass into acceleration, m into a. 5mg is equal to m into a. gets cancelled. AA is equal to 5G upwards. 5G upwards. To find AB, acceleration of the block P. Observe here, okay? Apply Newton's law of motion for this block P, okay? Which is चलाने वाला, okay? 2mg plus 3mg, which is रोकने वाला nothing, okay? Is equal to mass into acceleration, 2m into AB. 5mg is equal to 2m AB. Gets cancelled. AB is equal to acceleration of the block P is equal to 5 by 2 g. 5 by 2 g. That is downwards. This is downwards. Hope you have understood this one. We have calculated, and AC is 0. Acceleration of the block C is 0 because the forces are balanced here. Hope you understood. We have covered everything. First, start with the last block, okay? 3mg. Kx3 is equal to 3mg. Kx3 is 3mg. This is 2mg. Kx2 is equal to 2mg plus 3mg is 5mg. How much is Kx1? This is mg plus 5mg, 6mg. Now, later you cut the spring, whatever they are given, okay? Instantaneously, that spring force will be equal to 0. Write down the other spring forces as it is. There is no effect on the other spring forces. Kx3, whatever we are written here, Kx3, and this Kx1 will be as it is, okay? This is spring 3, therefore we are written Kx3. This is spring 2, therefore Kx2 spring 1 is Kx1. Kx2 is 0, Kx1 and Kx3 will be as it is. Now find the accelerations of different blocks, whatever they are given. Let us go to the next problem. It is saying here, the system shown in the figure is in equilibrium. Acceleration is 0, okay, forces are balanced, and all the blocks are at rest, okay. Assume that the masses of the strings, okay, these are the strings, the pulley and the spring are negligible with respect to the masses of the blocks, and friction is absent, okay. Find the acceleration of block C, okay, just after cutting the string 1, okay. First, let us write the weights. This is, okay, what is the weight? 2 into 10 is 20 Newton, okay, 20 Newton. If this is 20 Newton, okay, this is how much will be the spring force? Kx equal to, directly I can write 20 Newton itself. How much is Kx? Will be 20 Newton. Write down the weight. 1 into 10 is 10 Newton. Okay. Now here, how much is the tension? Tension will be 10 Newton plus 20 Newton is 30 Newton. Since it is connected with the same string, okay, C, tension will be same here. T will be how much? 30 Newton, and here also T will be 30 Newton. This is connected with this string, okay, string 1 and 2, okay. Neither it is चलाने वाला nor it is रोकने वाला, okay. It is just on the lying on the ground, okay. Whatever mg is there here, okay, whatever mg is there, this 50 Newton, okay, 550 Newton, and normal reaction is how much? Same as 50 Newton. This gets cancelled, okay. This gets cancelled, okay. This gets cancelled. There is no, okay, any force because of this 5 kg block, that we have to understand. Therefore, string will be having the same tension, okay. How much T is equal to here? 30 Newton. Same, this is connected with the same string 30 Newton, and there is no effect of force because of this 5 kg block, and tension will be same here 30 Newton, okay. This is string 1, this is string 2, you'll be having same tension here. Now what exactly we are supposed to calculate? Understood? After writing the spring force and tension, let us find what they are asking. You are supposed to find the acceleration of block C, okay, just after cutting the string 1. Now string 1 is cut now. Let us write here, okay. String 1 is cut now. String 1 is cut, tension will be how much here? Tension will be 0. And now tension changes here, T dash. Okay, this will be what? T dash. Instantaneously tension changes in the string, in the other string, but there is no effect on the spring force, will be as it is. How much it was? 20 Newton. This will be 20 Newton itself. This is 10 Newton. Spring force is Kx is 20 Newton. Now this tension decreases. Earlier how much it was? Earlier the tension was how much? Earlier the tension was 30 Newton. Now the tension decreases. Because of the tension decrease in the tension, acceleration will be towards down. Okay. Now here acceleration of this block will be how much? Forces are balanced. AA is equal to 0, and now this is AB. Okay. Now with the same acceleration, this block also moves. Okay. AC. Whereas yes, AB is equal to what? AC. AB is equal to AC because it is connected with the same string. Now let us find, okay, what is the acceleration of this block. Now if I take this as system boundary, what will happen? Okay, these two forces gets cancelled, internal forces, T dash gets cancelled. Now I can use Newton's laws of motion. चलाने वाला, which is चलाने वाला 20 plus of 10 चलाने वाला. रोकने वाला is nothing. Okay, nothing is equal to mass of each block. How much is the mass? 2 kg. Okay, 2 into A, 2 into AA plus of 1 into AB plus of 5 into AC. 5 into AC. Now 20 plus 10 is how much? 30 is equal to 2 into AA is how much? 0 plus of AB. Since AB is same as AC, I can write 5AB. Okay, that is equal to 30 is equal to 6AB. AB is equal to 30 by 6, 5 meters per second square. Similarly, AB is equal to AC is equal to how much? 5 meters per second square. Hope you have understood. Okay. There is no effect on the spring force. The tension in the other strings changes once if the string 1 is cut. There is change in the tension in the other string. Hope you understood. 5 meters per second square is the right answer. That is the acceleration of block C. Next, we'll go to the next problem. It is saying same problem. In the following setup, fully string and springs are light. Initially, all masses are in equilibrium and at rest. Find the tension. Okay, just 4. First, write the weight 4 mg. This is how much? I can write this as kx equal to 4 mg. Directly I can write. Start from the end. Okay. Now this is how much? Kx equal to 4 mg. Write on the weight here also like this 4 mg, and here will be mg plus 4 mg. How much the tension? Tension will be 5 mg. Same tension will be there here, 5 mg. Okay, there is no force because of this one. There is no weight. Okay, because weight and normal reaction gets cancelled. It is not hanging. Neither it is चलाने वाला nor it is रोकने वाला. Okay, now tension will be 5 mg here. Now find tension in spring and find tension in spring that we have calculated, and tension in ropes. Okay, that spring force is how much? 4 mg and tension is 5 mg. Okay, no. Find acceleration of masses immediately after the string S3 is cut. Okay, now S3 is cut now. Okay, what happens? Tension here will become 0. Okay, now there is a change in the tension here. I'll call this a T dash, and here also T dash. There is no effect on the spring force. Spring force will be as it is. This is 4 mg. This is mg. Kx is equal to 4 mg as it is. Tension changes. Okay, now you are supposed to calculate tension here. Okay, now here earlier how much was tension? 5 mg. Now T dash will be less because this is cut. Okay, now where will be the acceleration? Acceleration will be here, AB. Where will be the acceleration for block A? That is C. Here it is 0 because forces are balanced. Okay, for A is equal to 0. AB. Okay, this block also moves with the same acceleration like B block. Okay, because they are connected with the same string. Okay, now let us find what? AB. How to find AB? Just now we have seen. Write down the system boundary. If you take the system boundary, these two internal forces gets cancelled. Tension gets cancelled, which is चलाने वाला. These two, that is 4 mg plus mg, रोकने वाला is minus, equal to mass into acceleration. How much is the mass? 4m into AA plus of m into AB plus of 3m into AB. That is equal to 5 mg is equal to 4m into 0 is 0 plus of m AB plus of 3m AB. So 5 mg is equal to 4m AB. mm gets cancelled. AB is equal to 5g by 4. Okay, this will be downwards. Okay, it is same as this one. AB is equal to 4g by 4. This will be moving with the same acceleration. Acceleration of block m and 3m is same. Hope you have understood. Okay, now we have calculated tension in spring and tension in ropes. How much tension in spring is 4 mg. Tension in ropes is how much? 5 mg. Now acceleration of masses immediately after the string S3 is cut. Okay, string S3 is cut. Now AA is equal to 0. Okay, AB is equal to how much? AB is equal to 5 by 4 G. Okay, downwards. AC, this is also AC. Okay, I can call this as AC, block C. If this is block C is come, this is AC, same as A. That is equal to 5 by 4 G. Okay, this is downwards. Okay, downwards, and this is leftwards again. Okay, now anyway, we'll go to the next problem. Now two blocks A and B of mass m and 2m respectively are hanging from a ceiling by means of a light spring and a light string as shown. Okay, if the string between the blocks is suddenly cut, okay, this is cut, then find the acceleration of block. It's very easy. This is first write down the weight 2 mg. Okay, this is write down the tension. Tension is directly 2 mg. This is tension is how much? 2 mg. This is the weight mg. How much is kx? Kx is, add these two. 2 mg plus mg is 3 mg. Okay, now what is happening? Okay, after writing the tension and spring force, okay, after writing the weights, after writing the tension and spring force, we are supposed to cut the string that is between what? Block A and B. If this is cut, if the string between the blocks is suddenly cut, which is cut, this is cut. If this is cut, what happened? Tension will be 0. Okay, tension will be 0. This weight to mg and this weight is what? Mg. What happens to the spring force? There is no change in the spring force instantaneously. Kx equal to how much? 3 mg itself. Since this is 3 mg, this is mg, acceleration of the block A will be upwards. Okay, A will be upwards. What happens to the acceleration of the block B? This is 2 mg is downward, this will be no upward force, therefore this will be AB. AB will be downwards, A will be upwards. Now let us find what is AA and what is AB. To find AA, okay. Now, which is apply Newton's laws of motion for this block. Chalane wala, okay, will be how much? 3 mg minus rokne wala is how much? Because 3 mg is in the direction of what? Acceleration. Plus chalane wala minus rokne wala is mg is equal to mass into acceleration. M into A. 3 mg minus mg is 2 mg is equal to m into A. Mm gets cancelled. A is equal to 2g, that is upwards. 2g upwards. Now let us find AB. How to find AB? To find AB, apply Newton's law for this block. Okay, चलाने वाला is 2 mg, रोकने वाला is nothing. 0 is equal to mass is how much? 2m is given. 2m into AB. mm gets cancelled, that is 2 mg is equal to 2m AB. mm gets cancelled. Okay, 2 gets cancelled. AB is equal to what? G. This is downwards. Downward acceleration of block P. Hope you have understood this one. Okay. Now let us go to the next problem. Again, this is also same type of problem. Only here the masses are changed. Here m 2m was there. Now here m 2m is there. First write the weight mg. This is 2 mg. Okay. How much is the tension? Tension is same as this weight. T is equal to mg, and this T is equal to how much? Mg. Always you know tension, you have to write away from the block. You have to use the tension, not take the tension. Okay, that we have discussed in the previous videos also. This is how much is the spring force then? 2 mg plus mg is how much? 3 mg. Okay, small mg they have given this time, 3 mg. Now if this suddenly this is cut, okay, suddenly if this is cut, what happens to tension? Tension will be 0. This will be mg, weight is mg as it is. This is 2 mg. There is no effect on the spring force. Spring force will be as it is. Kx equal to how much earlier it was? It was 3 mg. Let's see here. Okay, it will be Kx equal to 3 mg itself. Okay, now this is mg, 2 mg are weights, and tension is 0 because this is cut. There is no effect on the spring force. Spring force is 3 mg as it is. Now which is greater, 3 mg or 2 mg? 3 mg. Therefore acceleration will be upwards. Yeah. Okay. Where will be the acceleration for block P? This is no force here, upward force, only downward force, that is AB. Okay. Now let us find AA, acceleration of block A. Observe here this block A. Okay. Apply Newton's laws of motion. चलाने वाला is 3 mg minus रोकने वाला is minus 2 mg, right, is equal to mass into acceleration. Mass is how much? 2m. Acceleration is AA. 3 mg minus 2 mg is mg is equal to 2m A. Understood? This m gets cancelled. AA is equal to g by 2. That is upwards. Now let us find AB. To find AB, which is चलाने वाला is which is mg, रोकने वाला is nothing, minus 0 into mass into acceleration. Mass is how much? M into AB. Okay, that is equal to right here itself. Mg is equal to m into AB. Mm gets cancelled. AB is equal to g. This is downwards. Now this is acceleration of block P and this is acceleration of block A. Let us see the answers. G by 2 comma G. G by 2 comma G. This is the right answer. Hope you understood all these sums. If you like this video, kindly share with your friends. Ask doubts in the comment box. Do not forget to subscribe for my channel. Like the video. I wish you all the best for your KCET, NEET and IIT JEE examinations. Thanks for watching this video.